right, so now I'm going to do an example similar to problem 2 in Logic 2 on the Logic 2 worksheet. All right, so we're going to consider first the statement or the proposition if x is less than 5, then x is less than 6. Okay, so in this problem we're asked, is this statement true or false? Why or why not? Okay, so let's first say, okay, let's look at this. Is this statement true or false? All right, so you can, it's true, right? If you're less than 5, then you're definitely less than 6. Right? If a kid is 4 years old, then it's true that they're less than 5. If they're less than 5, then they're definitely less than 6. Okay. Now, why? Why is this true? You could do something like this. Just draw a number line. Say 5, 6. This is a perfectly good explanation for why or why not. Is this true? Say yes, true. Now, why or why not? Well, here we go. Here's a number line. The number line shows it all perfectly. Okay. Okay, part B in that problem, problem 2, says, is the converse true? Okay, so this is the original statement. Let's figure out what the converse is. Okay, remember that let me write it this way. Okay, so the converse of P implies Q is Q implies P, or the converse of if P then Q is if Q then P. All right, so that we can consider this, we can think of this as our P, this is our Q. So our converse is if x is less than 6, then x is less than 5. That's the converse. Okay. Now, so if someone says, what is the converse of this statement? This is the converse. Now, we're not saying is the converse true or false, we're just saying what is it? The converse happens to be this. The converse of P implies Q is Q implies P. This is our converse. All right, so now you might say, well, is the converse true? Okay, and the converse is not. It is false, right? So this is false. Now why? You can draw a number line again. Right? So you could have x here. It could be that x is there, right? If x is, so this is not true for all x. All right, this is not true for all x's. Here we have a counterexample. Here x is less than 6, but it's not true that x is less than 5. So this is a false statement. Okay. Okay, now part C, contrapositive. Okay, the contrapositive of P implies Q is not Q implies not P. All right, so the contrapositive of this is if not x is less than 6, then not x is less than 5. Oops. All right, but this is really cumbersome. How do we wrap our mind around this idea that it's not the case that x is less than 6? That it's not the case that then it's not the case that x is less than 5. All right, so we can write this in a much better form. Okay, to do that, let me illustrate the point. Okay, what does x is less than 6 mean? With the number, we can look at that with the number line. Okay, maybe put in 0 just for reference. Here's 6, right? If x is less than 6, then that means that we're talking about all these numbers here. Another way you might have seen this before is with this little thing like that, right? 6 there. Okay, so if it's not the case that x is less than 6, then it's not the case that x is over here. Then that means that x is over here or x is at 6. So if it's not, so let me say that again. So if it's not the case that x is over here somewhere, then x has to be over here somewhere, or x could actually be 6. So the negation so if it's not the case that x is less than 6, then x is bigger than 6. Or x equals 6. Okay, and so a nice way to write that, okay, so think about that, right? So if so it's not the case that x is less than 6, then that means that x is greater than 6 or x is equal to 6. Now the shorthand way to write that is a way that you've been writing for a long time. X is greater than or equal to 6. So think about the way you say that, right? Greater than or equal. This is an or statement. Okay? All right. So similarly, if it's not the case that x is less than 5, then x is greater than or equal to 5. Okay. So let's write this out with this new information that we have. So if it's not the case that x is less than 6, then x is greater than or equal to 6. So if x is greater than or equal to 6, then x is greater than or equal to 5. So let's think about that. Is that true? Yes, in fact, this is true. Let's see. If you're bigger than or equal to 6, then you're definitely bigger than 5, right? Or equal to 5. Okay. So this is true. And maybe some of you are like, hey, that doesn't make sense. But remember, it's an or, right? So if x is greater than or equal to 6, so if x is greater than 6, let's say x is 7, right, then it's certainly true that x is bigger than 5 or x is equal to 5, right? Because an or is true when one or the other or both. Okay. So it's true. All right, so, oh, and then how can we show this? We can show it with the number line again. Let's put a 5 there and a 6, and let's put x there. Here you see x is greater than 6, so x is greater than or equal to 5. Or if x is equal to 6, then still x is still greater than or equal to 5. So if x is greater than or equal to 6, then x is greater than or equal to 5. All right, now these two statements are equivalent, right? We just changed the way, we just kind of conceptualized what this odd concept of not being less than 6 meant was that. So because they're equivalent statements, we can write this, right? Remember, like equals for logic. This statement is equal to that statement. All right.